And I'm going to go through the options one by one. So first we go through the system settings. I compiled with MBAPICH 1, which is MPICH for the InfiniBand fabric, so that's correct. I want to use the debugger, the automatic debugger selected by DDT. That is fine. So I'm just going to click OK. And now I'm going to change the queue submission parameters. I'm going to submit to this queue that you don't have, but you should submit to development or normal. Either of those will work for you. Wall clock time, I'm just going to say half an hour. And here you should specify that project that I mentioned before, that was 2010-07-06 HPC. But you have it on the slides for reference, so you can look at that later. And I'm going to specify how many cores per node, so I could go one way, two way, 16 ways the maximum I can choose in Ranger, so let's run 16. And click OK, and what that's going to do is that's going to produce a queue submission script for me, so I don't have to take care of that. The number of processes is already set to 16, which is fine. And I'm only going to be running one thread. There's no OpenMP part to this code, so I just leave it at 1. If you were running a hybrid code, you could be running, for example, 4 MPI tasks and 4 OpenMP threads for a total of 16 for the 16 way. Or if you were running a pure OpenMP code, you could be running just 16 threads and just 1 MPI task. So all those combinations are acceptable. Let me open advanced to make sure we have memory checking enabled. So we go down here and memory debugging is enabled. Preload memory debugging library is enabled as well. The language options that we have are C, Fortran, no threads, C, Fortran, threads, C++, threaded and non-threaded. So I'm going to go with C and Fortran, C or Fortran and no threads for this case. Heap debugging, I'm just going to set it to low, and the rest I'm going to set it to the default. Click OK, and we're ready to submit. Before I do that, some of you might work with Fortran codes, Fortran 90 codes that require an input file. In that case, you shouldn't put it on the argument list. You should actually specify the input file here in this line at the bottom. You can just browse your system for whatever input file you need to give to your own program. And that's because the way that Fortran 90 actually gets things from the input, if you don't put it there, you might sometimes DDT might get confused. So that's just in case you have a code like that. For this example, we don't need anything other than the arguments. And now we hit submit, and I hope there's not that many people using systest. If this part takes more than 2 minutes, I will go to a different system where the queue is pretty much empty right now. But let's give it 1 minute or two. Also, while I'm doing the demo, if you have any questions, please let me know. Okay, I'm gonna start preparing the same thing in a different machine just in case. I just canceled my own connection. That was nice. So that's just still waiting. Oh, okay, here we go. So, okay, that's wonderful. So one thing is, right now in this system, all the text is made of really nice square boxes, and I can usually get rid of that by changing the font in the options, appearance, font. Let's make it a bit bigger. Let's see if that works. Yes, okay. So hopefully now everyone can see on the center of the screen the source code, and I just moved one of the windows. Okay, so one of the first things that I'm going to do is I'm going to set up a breakpoint just before the main calculation starts, and I can do that in several ways, but for me the easiest is just to double click on that line. So let me see where the main loop is. Main loop. So I'm going to put a breakpoint on line 57, and I'm just going to let these play. So to start the execution, we can go to the top left corner and just hit play, or you can hit F9. And now the execution has stopped. You see that the different tasks are no longer changing color between pink and green, which indicates that they're communicating. And you can see that the highlighted line in the source code window corresponds to the first code line after my breakpoint. Also, you can see that in the local variables window on the right, all the variables that appear in this line have been selected, and we have the different values for them. So in this case, just number of iterations 10, as we expected, and n, which is the loop ID, and it's not started yet, so it's just set to 0. If we change to other processors, so task number 1, for example, that's refreshed, and hopefully the number of iterations will remain the same for all of these guys, because otherwise we have a problem with the encounter. So that seems to be fine. In fact, what I could do is go to View, and then cross-process comparison, and here I could choose, say, my rank, which is the variable that I assign to the actual process ID, hit compare, and I should see a list here where every process has a different ID, which is what is happening. So what I'm seeing here is that process 15 has my rank 15, process 10 has my rank 10, etc. You could visualize that, but that's pretty boring because there's really nothing to visualize there, just the IDs, and the statistics are irrelevant in this case. I could also make sure that everybody knows what the number of processors is by looking at the variable numprox, and in this case DDT already collapses everybody and tells me yes, processes 0 to 15 have the same value of numprox, which is 16. So that's all working fine. Now what if I want to do something a little bit more complicated, and I want to have a look at the values of an array? So let me see what arrays I have here. I have this array called buffer, and what I'm going to do is I'm going to look at, again, a cross-process comparison of buffer, and I'm going to write the expression as if I was writing in C, so buffer of I, and then I want to hit array mode, and I want to evaluate from, say, 1 to 4, well, or 0 to 5, and hit compare. Now you will see that I have a list of processes separated by groups, and I have a plus sign on the right that I can click, and if I double click that, I will get a list of all the values that buffer has for the processes on the left. So process 0 has values 3, 0, 1, 2, 3, and 4. Processes 1, 6, and 11, which is the following line, have 3, 4, 5, 6, 7, 8, etc. So you get the idea that you can have a look in this cross-process comparison not only to scalars but also to 1D arrays, which can be pretty useful. Okay, so once I've done this, I think I'm just going to continue and see if the code actually runs. So I'm going to go back to the top left and hit play again, and now DDT is going to complain. It's going to say process 15, program is stopped at MPI errors are fatal, which means we had a serious MPI error. So I'm not going to continue, I'm going to pause execution here, and essentially what's happened right now is that I have put a dynamic breakpoint. DDT told me there's a serious problem, if you continue I'm going to crash completely and get out of the execution stack, so do you want me to stop before that happens? And I just did. What I can do now is have a look at the stack, either on the local variables window or in the stack window, and in this case I'm going to favor the stack window. Let me choose stop. Okay, now everybody's stopped. I'm sorry about that, I forgot to pause the execution. I just told it to pause, but it didn't do it for me. So now when I look at the stack, I can see where each of the processes is, but looking at the stack in the local variable window is a bit painful because you would have to select each of the processes individually. So what you actually want to do is you want to come down here to the bottom window where the breakpoints, watches, and stacks are, and go to the stack tab. Once you go there, you will see that essentially everybody, and what I'm doing is just hovering over the last function call that appears there. I have a bunch of processes stopped at line 67, and that seems to be an MPI receive. So there seems to be some problem in this line 67 with an MPI receive. So let's go to that line 67. And I'm having a bit of trouble because this screen is a lot smaller than I'm used to. Okay, so we're here, line